Hello again. This second part of our lessons on electricity and electrification, building electrification movement, is going to look a little bit more about electrical consumption in buildings, particularly in residential buildings, which are a focus of studio and our coordination with the collective's studio efforts. So household electrical use varies from country to country. And as you can imagine, it depends quite a lot on the respective wealth of the countries using electricity, but also very much so on the sources of electricity and availability of the energy to produce electricity. As you can see from this chart, the United States and Canada have the highest amount of electrical use of any of the countries listed here. Some of these are due to the consumptive nature of the two countries, but also the fact that both countries are blessed with a high amount of energy resources, which keeps the price of these energies lower, and therefore, as we know, the consumption of it is higher. Countries which have both less wealth to consume electrical products as well as less resources on production of electricity are obviously going to be having a less electrical use. So this combination of resources and consumption patterns are really what drive the use within different countries. Consumption patterns, cost, and that's directly related to the availability of fuel sources. In the United States, a typical household power consumption is about close to 12,000 kilowatt hours each year. We learned in the previous lesson just what a kilowatt hour is in terms of a measure of power consumed. In France, this is only at about 6,400 kilowatt hours. In the UK, 4,600. And in China, about 1,300 kilowatt hours. So these numbers should be taken with a little bit of grain of salt because they refer to averages. And averages, as we know, find the middle ground between the lowest and the highest. But it should give us a sense of the relative difference between how much household power is consumed in the U.S. relative to other countries in the world. The global average for electrical consumption for households with electricity was roughly 3,500 kilowatt hours. This is in 2010, before the upsurge in use of electricity really began. Averages are difficult to measure given inequities and wide disparities of wealth between nations, but they give us a clue. There are numerous things that drive these differences, including wealth, physical house size, appliance standards, electrical prices, and access to alternative cooking, heating, and cooling fuels. It's worth reviewing again just what we mean by a kilowatt hour. It's a measure of consumed power, watts times time, divided by 1,000. That gives us an amount of comparable electricity consumed from various sources that we're comparing. With all this said, Americans use about 5 times more power than the global average. Each American uses about 4,500 kilowatt hours per year in their home. This gives us a number that we can target as we want to reduce our consumption of energy or find more efficient uses for it. This is about 6 times the global average per capita, or more than 5 times the average for those who have electricity access, which is probably a better comparison. The variation between developed countries is also quite stark. While the US and Canada are up around 4,500 kilowatt hours per person, the UK and Germany are below 2,000 kilowatt hours per person. If you think about how you consume electricity, your daily patterns of use, it can give you some kind of an indication of where that 4,500 kilowatt hours per person comes from. In Brazil, Mexico, and China, the per person use is just 500 kilowatt hours. But growth is very different. In Brazil, residential use per person has been stable over the last 20 years, whereas in Mexico, it is up 50%, And in China, it has increased 600%. Some factors which explain why consumption in China is low, and in India it's even lower. Perhaps the most surprising thing in this chart is that the global average is as high as 3,500 kilowatts per year, given that the figures for India and China are so low. They're the countries in the world with the largest population. Two things explain this: household size and electrification rates. In China, about 99% of people have electricity, and the average household size is around 3. So less consumption per household. In India, the numbers are 66% of the people have access to electricity, and 5 is the average household size. In Nigeria, 50% of the people have access to electricity, and the household size averages at 5. So we can see as these two countries, India and Nigeria, those very populous and prosperous countries, are going to be increasing their demand for the use of electricity as the countries develop and these technologies spread to more people. And so, as we spoke about earlier, the availability and demand of electricity for electrification is a key issue, a key topic of the challenges for the program. But the average household size in most wealthy countries is closer to 2.5 people. As a result, the distribution of electrified households is more skewed towards wealthy countries than population in general. And that number also gives us a real indication about the per capita, per individual use of electricity in the United States, and really challenge us to consider how we use electricity and how much of it we use, and to accommodate and adjust our usage to lower our personal consumption. So how can you calculate the amount of electricity a home might use? You need to know the power for each of the appliances you use and the time they are used, right? It's a pretty simple calculation that you can make. Total for all these consumptions within the billing period, let's say a month or whatever that your service provider has for you, is equivalent to the consumption for which your bill is calculated. Most common appliances and lighting, together with a range of power most common in these devices. Here's some of the things people use all the time: televisions, air conditioning, huge consumer of electrical wattage, a microwave, even though used for short durations, high use, refrigerator, always on, and a constant draw on your power. Ovens, particularly as we're moving towards all electric ovens, are going to be a high consumer of wattage. Incandescent lights, which are pretty much extinct from our environment now. You can see that the energy uses for an LED bulb is 1/10 of what it is for an incandescent light. So to calculate your consumption, you multiply the power in kilowatts by the hours you use the devices per day, per week, or per month. So to find the daily energy consumption, use the following formula, right? Your wattage time hours used per day divided by 1,000, that's your daily kilowatt consumption. You can take your daily consumption by the number of days used per year, and that's your annual energy consumption. And then you can find the annual cost to run the appliances using the following formula. Annual consumption times utility rate per kilowatt hour equals the annual cost to run the appliance. These are formulas that we can all use to determine our energy consumption in our own abodes. These are not difficult to find out. Most, if not all, of electrical appliances and equipment are provided with tags, which gives you their wattage. And from that, you can then easily calculate your daily consumption and make the appropriate adjustments to your behavior. So let's look at one electrical load, an appliance, an electric kettle. So let's say the kettle is used several times a day to boil water for your tea or coffee, maybe about an hour. The wattage on the label is listed at 1,500 watts. So the daily energy consumption, 1,500 watts times 1 hour, divided by 1,000 equals 1.5 kilowatt hours. If you use that kettle every day, over the course of a year, you will use 547.5 kilowatt hours. Remember back to our in the previous lesson, what 1 kilowatt hour will provide you with in terms of different uses. A kilowatt hour would give you, 3.5 miles in an electric car. So using your electric kettle to make tea or coffee every day, 3.5 times 500, literally you can drive about close to 1,750 miles in your electric car with the same power that you're using to make your tea in the morning. The annual cost, if the utility rate is 11 cents per kilowatt hour, you can see that electric kettle is costing you $60 a year to utilize. Compared to something in your office like a paper shredder, now that we know how the system works, right? The wattage is not listed on the label for the shredder, but the electrical current draw is listed at 3 amps. So 120 volt times 3 amps gives us the wattage. Remember, amps times voltage equals wattage. So your daily consumption then, if you use it 15 minutes a day, 360 watts times 0.25 divided by 1,000. So your paper shredder uses less than 1/10 of a kilowatt per day. If you're shredding a lot of paper once a week, you can see that over the course of the year, paper shredder uses about 4.5 kilowatt hours, or about 15 miles in your electric car, and its annual cost is 50 cents a year. Energy remains very cheap in the United States. So how much power does an American house use? And in 2021, the average annual electricity consumption for a U.S. residential utility was 10,000 kilowatt hours. Recall, this is without building electrification. This is still using predominantly fossil fuels for heating and cooling, which will certainly go up as we move to an all-electric energy economy. That translates into about 886 kilowatt hours per month for a U.S. residential utility customer. Louisiana had the highest annual electrical consumption at 14,000 kilowatt hours per residential customer, a hot, humid climate with increased energy demand. And Hawaii, wonderful climate, right, had the lowest with 6,000 kilowatt hours per residential customer. Size of houses obviously have a large bearing on this. The bigger the house, right, the bigger the consumption. So here's another review of just how much the different major economies in the world vary in terms of their electrical consumption. Canada actually being more than the United States. Some of that might be related to being further north and more light consumption. Colder climate, maybe more energy, electricity used in the production of heating and cooling. But it does relate to the size of a house. We have big single-family homes in the United States, big apartments. A 2,000 square foot home might use 1,300 kilowatt hours, and as the size of per month, 1,300 kilowatt hours per month. And as the size of the house increases, you can obviously see that the electrical consumption increases. A 4,000 square foot home consumes a lot of power. That's a 4,000 square foot home, which is a pretty good size, but maybe not even large by current standards of suburban development. How much does electricity cost? Well, this is a factor, as we discussed earlier, in terms of resources and available resources for producing electricity, but also government taxation policies and policies to involved to reduce the consumption of electricity, which in our country we're blessed with a lot of resources for producing electricity, but also with a particular conservative mindset, which helps to keep taxation and other fees low, these are funds which could be used to further develop our electrical and energy infrastructure. So our policies are a bit askew. We're awash with energy, but that means we consume more, and the consequences of it are quite apparent. Across the United States, the cost of electricity varies, as you can imagine, based on the same topics we discussed earlier: the availability of fuels to produce electricity, and then government management of the price of electricity through taxation and other fees, which are used to develop alternative energy to provide um, um, rebates and enticements to use more efficient energy. So you can see here, a state like Texas has electricity costs of 12 cents um, per kilowatt hour, which is near the average in the country. Some states, as you can imagine, producing electricity in Hawaii is very expensive because of the limited resources and the far transmission of power to get there. California, with its environmentally active policies of taxation and government management, has higher energy costs than you might think from a state that has the resources that it does. So this is pretty interesting to look at and see where your home state falls on both the consumption and the cost. You can see there's a pretty good mapping between the electrical use per household and the cost of electricity across the different states in the U.S., just like we're seeing there is in different countries in the world. So if we turn our attention now to key design areas for our building electrification efforts, some of the things that we spoke about earlier are directly related to what you are working on in your housing studios, key areas of domestic space, but also then areas within the common and shared building itself. Induction cooktops are a special type of electric cooktop that gets its power and precision from induction technology. This means it generates energy from an electromagnetic field below the glass cooktop surface, which then transfers directly to a magnetic cookware, causing it to heat up. This can give the control over cooking, the precise control that many cooks like from natural gas, the ability to quickly adjust heat and to reduce heat to zero once the fuel source or the power source is turned off. So the developments in induction cooktops is going to travel apace with the gas bans that we're seeing different cities such as Berkeley and Ann Arbor consider for their communities. Professor Younghans, our other Lars, gave us a good overview on electric air heat pumps and their efficiency, as well as their promise for reducing fossil fuel usage. And so please review his lesson about this and follow this link here to a good overview on heat pumps themselves to refresh yourself with how these systems work as they are becoming a more and more common and crucial component in our overall efforts to reduce our reliance on fossil fuels. As we know, these work in both heating and cooling cycles. They can reverse themselves through their two their two coils, and their pressurization of Freon or other transfer liquids. So make sure you kind of understand the basics of how these systems operate. And check out this very accessible and interesting article in Washington Post written for consumers rather than for architects or electricians or mechanical engineers, which gives an overview of heat pumps and decisions that one might make in terms of adding one of these to your home. Electric vehicles obviously are something which is a huge factor in terms of reducing our overall reliance on fossil fuels, not directly related to building electrification. However, it is in the sense of finding um, sources of energy to provide this massive increase in electrical energy that's going to be needed to provide our automobiles. The development of these electric vehicles is at both ends of the spectrum, from large pickup trucks used in construction and all kinds of work-related and industry-related activities at both the personal scale and the commercial scale, and then the development of smaller, more flexible automobiles for use in urban areas and for some of the small tasks of moving around that we typically jump in our big automobiles to do. However, the consequences of how to uh, power up these cars, power up these electrical vehicles in our society, is both a infrastructural issue, but it's also a design issue. If we're replacing gas stations with these types of rather soulless and let's just say awful environments for plugging our cars into electrical services such as this, we designers have our work cut out for ourselves to reduce the asphalt footprint of America, the services that we uh, dedicate to the otherwise non-productive use of moving our automobiles around and storing them in places. Um, the charging system infrastructure is actually becoming more nimble and becoming more smaller and more flexible as electrical cars are more embraced and more used, and the ability to charge at home through a simple adjustment to your home electrical system is rapidly coming in line. DTE, the local energy provider, has a program to install a home charger in your home and prorate the cost for this over an extended period of time to make it more affordable to homeowners. What this means, as we said, is this electrical transmission grid that we looked at earlier is going to become denser and denser and denser and finer grained to provide this range of electrical service, both in urban and rural areas. What does it mean is that some of the spaces in our homes that we once assumed were a particular character, the dirty garage with a stinky carbon monoxide producing automobile within it, now it takes on a completely different character if all we're doing is plugging the automobile into a recharger the same way we might do with our iPad or our telephone. Very different kind of relationship to the spaces of the home between the space for the automobile and the space for living that we've been used to since the dawn of the gasoline powered automobile. So designers are imagining, completely different futures where your couch and your TV and your television and your automobile might all be housed in the same room. We've also seen systems where battery storage systems for electricity, particularly from home solar uh, production, can be used to charge an automobile. But in the reverse case, during power outages, we've seen situations where the home has been then powered by the battery within the automobile during power outages. So there's a symbiotic relationship between the electrical systems of the automobile and the home are fascinating areas for both technological development and design applications such as we see here. So to give an overview of all that we've talked about sort of today, we've looked at the goals of building electrification, the opportunities and many of the challenges. We've got some sense of the overall production and distribution of electricity in the U.S. Market, but also in related to some of the larger countries and larger economies in the world, and the inequities and disproportionate uses of electricity in various countries, from the very wealthy to the developing countries in the world. We've had an introduction to electrical systems in buildings, and then a brief review of some of the basics of electricity, power consumption and how we can calculate consumption within our residences. And then also to calculate the costs of that consumption in our residences. And we looked at a few key design areas for building electrification efforts.